Now we'll see write back procedure. Before going to write back procedure, first summarize the write through procedure. In write through procedure, case number 1. First of all, I don't assume that I have write buffer. Without write buffer, write through, simple plain write through, and cache hit occurs. That means you are searching for a word and it is available in the cache and you are reading. Let us see all the cases. Of course, read is not required because read is quite easy. Then we'll see write. Now you want to update a word and which is already available in the cache, simply update it. Okay. Then immediately go to the main memory and update it. That's it. That is about cache hit and write. Second thing, what if cache miss occurs? If cache miss occurs for write, that means wherever you want to write, that word is not available in the cache, correct? So that means what, we don't have data in the cache. Then what to do? One thing what we have to do is, first of all we have to go to the main memory and identify the write block and copy it first. Okay, so this is the block where our word is there. Okay, transfer it somewhere. Then after that, in the appropriate, then you get the your desired word, right, and you update it. Now in main memory also you update it. These are the three things you should do, but any order you can do, not a problem, right? This is about write through hit and miss cases, right? When hit occurs, what to do, miss occurs, what to do. Now write through plus buffer, right? We have a write buffer. When you have a write buffer with write through procedure, then what can we do is, first thing, let us take the case called hit. If it is a hit, then directly go to the cache and data is available and update it. Update the right word which you want to do. Then immediately processor continues with the next instruction. Okay, that means processor won't take the data and it won't write here. Rather than that, processor will continue with the next instructions, but there will be a write buffer. Write buffer contains the updated data, right? That updated data will be transferred to the main memory independently, parallelly. Understand? That means it will be effective, right? There is efficiency, correct? Now processor is effectively executing next instructions and this buffer is transferring the data. For that you should have extra circuit so that it can automatically do that. Understand? But the only thing is, no one should use that memory at that time. Second thing, sometimes what happens, this buffer will be I can say full, it will become full. Why? Example, let's say you have instruction number 1, that is store instruction. Then what we do, immediately we store here, assume that let's say cache hit occurs, then we write here, then we write the data in buffer also. Second instruction, now you processor went to executing the next instruction. In next instruction also, let's say that is write. Then what happens again, you will come to the cache and you update somewhere and you fill it in the write buffer. Because what is the purpose of write buffer? Write buffer is going to hold the temporary data and which is going to be transferred to the main memory. Since transferring main memory to main memory takes lot of time, correct? Already I told you how many cycles it takes, 100 cycles or 50 cycles. That's why before these 50 cycles, your processor might execute lot of instructions in that 50 cycles of time. Then new store instructions might encounter and it will fill your buffer. Try to understand. If buffer is also very fast, if that buffer also can do transfer from data from this here to here in 1 nanosecond, there is no problem. But that won't happen. If it happens when one cycle, if we can write in main memory, then why we use cache? That's why main memory is so slow, right? That's why. So this buffer sometimes becomes what? Full. At that time, what to do? Your processor should wait. Why? If processor don't wait, then what you have to do? Then for that instruction, you have to go to the main memory and you have to write it. It takes lot of time, correct? And maybe this important information might be required to that processor. That's why we have to wait if this buffer is not transferred here. Understand? Two reasons. If there is no space, then where you keep the next data? Understand? That is about write buffer, right? Now we have not completely discussed write buffer, right? Write buffer, finally hit case. In the hit case, what we do? We directly come to the cache and we update the word and we keep the data in the write buffer, so that whenever write buffer gets time, it will write in the memory. Okay. Now second thing, if cache miss occurs, last case, write through and cache miss. Okay, miss here I write. If it is a miss, that means what? Data is not available. This is your data W, but it's not here. Cache miss. Then what to do? First, transfer all the data to, because we have to transfer all the data, right? Transfer all the data to cache. Okay. Now update it. Then give the data to write buffer. My dear write buffer, please, whenever you get time, I am giving memory address and data, go to the main memory and write it, and processor will continue with the next instructions. In that way we can at least reduce some time. Okay, so this is about write through procedure. Now we'll see write back procedure. Okay, so in write back procedure, what are we going to do is we are going to postpone the transfer. That means this is your cache. First we take hit case. Okay, and we are talking about write back and write through procedures, especially for writes, right? Read is very easy. Now you want to write some data, but data cache contains the data. This is the word you want to update. Okay, now cache has it. Then what to do? In write back procedure, simply we update it. That's it, very quickly. Correct? That is nothing but accessing the cache. We access the cache, we access the write word, and we modify it. Then we don't store it in main memory, and we will have that inconsistency with us. Okay, that means there is an inconsistency. That means, example, this data is 30, but same word might be 20 here in main memory. So then suddenly someone access this main memory. Who will access? Already I told you, right? There is a disk sometimes independently access this main memory. So when transfer from main memory to disk occurs, then at that time, so somehow your circuit, your processor should be centralized, so it should understand, and first at that time in write back procedure, forcefully this entire block will be, because we don't know which one is updated, so this entire block will be moved. Then later direct memory access will happen. Direct memory access is, we will be discussing later. At this moment you say transfer from main memory to disk is called direct memory access. Okay, that's enough. Understand? Now let me summarize. Hit case. Whenever there is a hit in the write back scheme, we will update only the write word in the cache, but we don't update in the main memory. But suddenly when some external event occurs and that wants to take the data from main memory, then immediately the corresponding block will be moved. Understand? Now second thing, the second reason I will tell you when we will move. Example, let's say, forget about this case where disk is not accessing any main memory. Okay. Now the other case is, you have updated here but you have not updated here, right? Inconsistent data. Sometimes what happens, let's say this block is main memory block 50, okay, B50. Now we know one thing, we have cache replacement techniques, right? That means what? Always we can't keep this block in the cache, right? Sometimes we have to replace this block with another block. Suddenly, let's say we want to keep a block called B60 because of our scheme. But B50 if you simply erase, and if you keep B60 here, block 60 here, then what happens? Then the updation will be gone, right? It shows again wrong answer. That's why whenever you have a block B50 which has some modification in write back procedure, it happens that cache contains some data which is not present in, cache have some updated data which is not updated in main memory, right? Then at that time, let's call it as B50. This is your B50 block. Then first we transfer all that B50 data here, so that 30 will come here. Then later we replace it. Understand? So that is important property of write back procedure. Understand? Now finally you understood how hit happens. How hit happens? Whenever there is a cache hit, we'll be happy. Directly go to the word and update it. Don't update in the main memory. But whenever that block which you have updated here, if that has to be replaced, sometimes we replace, correct? Cache replacement policies we have studied. least recently used policy we use, right? Because of that, if your block is a victim, then at that time ask everyone to wait and simply move this block first of all to here, and so that your main memory also will be updated. Then later you erase the data. Understand? So that is about hit. So what if miss occurs? If there is a miss, what happens? We'll see. If there is a cache miss in the write back procedure, this is your block, let's say. That means data is not available in the cache. When data is not available, but you want to update, simple. First transfer that entire block to main memory. Yes. Then after that, simply update here. That's it. Okay. So what we do? If there is a cache miss, then like write through, simply move that block to cache, and when you move this block here, maybe that block is occupied by, that cache block is occupied by another main memory block. Then we update that, we know that again, same story. That means whenever you move this block, example, that block will give numbers. Let's say this block number is B10. This is now currently it is B50. You want to keep B10 here because we are searching for B10. Okay, we want to update B10. Then simply move B10 here first. Before that, update B50 here, wherever. That means, example, this is B50. Okay, store the data of B50 back. Then later write into B10. Is it not complicated? Yes, it takes a lot of time. In write back procedure, if miss occurs, then it will be little bit complicated. Understand? Like write through, of course. So let me revise miss again. This is your main memory. This is a block. Let us call this as block number 1. Otherwise, let's say main memory block 1. There is another block called main memory block 2. Currently, this cache contains main memory block 2, okay, MB2. Now you want to refer a main memory block 1 because you want to update some word in that. Then miss occurs because main memory block 1 is not available, let's say. Then what we do, we replace main memory block 2 with main memory block 1. Sir, why you replace main memory block 2? Why don't you write main memory block 1 in another place? It depends on your cache, I can say cache technique, right? Mapping technique. Are you using direct or associative or set associative? It depends, right? Assume that it is direct mapping technique, and that direct mapping technique says that main memory block number 1 should go here. Then what to do? Simple. Simply move this main memory block 1 here first. Before that, all the main memory block 2, the content, please update here. Okay. Because you might have updated it before, right? In write back, sometimes we don't update in main memory. Recall. So if it is main memory block 2, why we have to move that main memory block 2 is because main memory block 2 might have been updated earlier, but we did not update in the main memory. That is what write back procedure. It happens in write back procedure, correct? So if you have such data, then first update in main memory block 2, so that now main memory block 2 is properly updated. Then write main memory block 1 here. Then after that you do whatever you want. What did you want? You wanted to update some word in main memory, correct? Update it. So if I update some word here now, but main memory block 1 in main memory is not updated, right? Recall write back procedure. In write back we do that later. Understand? So this is a way so write back procedure works. Even in for write back procedure also we can use write buffer, but I'm not discussing that things. Okay, you can just think about it. There are a lot of optimizations possible. That's why in GATE exam nothing is standard. They can't ask a particular question without explaining the complete scenario. That's why don't worry. Understand the concepts, that is enough, right? So understand the write back concept and write through concept. But in one line, can I say one thing? In write through, immediately we update. In write back, we postpone the decision rather than updating immediately. Whenever sometimes we have to replace one particular block, then at that time we will do that. And one more question. So when do we know that the data is modified or not? Sometimes it is required. Example, you have a cache block. If it is not at all modified, imagine if it is not at all modified, no word is modified, then happy. Then why to move that? Why to update in the main memory? Not required, right? That's why every cache block will have a bit called modified bit. Remember it, okay? Any word in any block in the cache is modified, we will make it 1. So that some blocks will get modified bit 1, some blocks will have modified bit 0. Now if you want to replace any block, if it is not at all modified, then we don't require to replace, right? I mean, we don't require to move it, correct? Let me show it again with one example. Let's say you have not modified block. This is, let's say, non-modified block. Okay, remember it. Now let's say I'm talking about a particular case called, of course, write back in miss. Okay, whenever cache miss occurs, generally what we do, we will go to the main memory and definitely we have to fetch it, right? Example, let's say we are searching, I mean, we are looking for main memory block 1, which is not available, but currently this is main memory block 2, but main memory block 2 in throughout its journey got not updated. That means nobody wrote anything, so that its modified bit or dirty bit is 0. Then in that scenario, what we have to do? Step number 1, directly, because main memory block 2 is not modified, then this content and this content same, then we don't really needed to update this one to here. Then happily go to main memory block 1 in the main memory and ask, my dear main memory block number 1, according to direct mapping technique, let's say, or any mapping technique, what is your position in cache? This one. Oh, then simply because its modified bit is 0, then happily we write modif MB1. That means we did not move MB2 to here because data is not modified. So we can reduce the time, right? That's why modified bit is used. Understand? If modified bit is 1, that means data is modified, then first we have to move the data to main memory. That block has to be updated. Then later our desired block should be brought, MB1. Then later the right word which you wanted to modify to be modified. That is about dirty bit or modified bit. Okay. Now I talked about only miss case, right? You think about hit case. Okay. Easily we can understand. If cache miss occurs, I'm sorry, if cache hit occurs and the procedure is write back, but data is already dirty, then what you do? Think about it. It's same, right? So this is all about write back and write through procedures. Understand?